Okay, this is Unit 5, Day 1, Intro to Polynomial Functions. These, and if I forget to tell the sub, the copies of these are available in the front of the room under the TV. So if they haven't passed them out yet, maybe remind them to go pass those out. So the learning target, I can identify and classify polynomials, and I can add, subtract, and multiply polynomials. You might feel like you've already done this before when we show you, especially the add, subtract, and multiply part. You probably think like this really isn't that difficult. It's just like terms kind of stuff, and you're right, it is. So don't overthink those. Now, a polynomial is a monomial or sum of monomials. Okay, so it can be a monomial or it can be the sum of several of them. A monomial can be a lot of things too. It can be a real number. It can be a real number. It can be a variable. Or it can be a product of those. Or a product of real number of a real number and one or more variables. With a whole number expression, or exponent. So it has to be, I'll put this, with a whole number exponent. So you can't have fractional exponents. If it has like x to the 1/2 power, that is not part of a monomial. So anyway, so let's look at these. Determine if the following are polynomials and explain if they're not, why they're not. So here, just to give you an idea, a monomial, here's a monomial, here's a monomial, here's monomial, and there's monomial. So there's 4 monomials. It says a sum. So even when we say subtract, you could say that that's actually just adding the opposite. So it's still addition, still a sum. They all have whole number exponents. So x is to the 5th power, that's a whole number. X squared is a whole number. X to the 1st, so on. So all of these are monomials being added together. So this one is a yes. This is a polynomial. This one here, this one is a no. Why? Because that exponent is an x. So the x is in the exponent. Can't have an x in the exponent. The exponent has to be a whole number. Okay, it has to be a whole number. This guy here, this one, technically, this is in the bottom. So I'd have to bring that up and make it a -1 power, which means it doesn't have a whole number exponent, it has a negative exponent. You know, whole numbers being positive numbers that are integers. So this one is no, does not have whole number exponents. So you can't have the variables in the denominator, basically. This guy here might seem kind of tricky. That radical looks tricky. It's okay for the coefficient to be a radical. It's not okay for the variable to be in a radical. So this one is okay. So this one is yes, that is a polynomial. This one here, if I multiply it all together, I'll save some time here. If you multiply it all together, it'd be 3x squared minus 12x minus 30, which follows all of these rules above. And this one here, that's a no, it's all under a radical. So that one is not a polynomial. So not a whole number exponent. Because if I wrote this to a power, that'd be the same thing as x plus 2 to the 1/2 power, and that's not a whole number exponent. So important vocabulary. The degree of a polynomial is the greatest power among the monomial terms. So the highest power that you see. So like this one here, the highest power I see is the 9. You know the 5 came first, it's written first, the 9, so that this would have a degree of 9. This one up here would have a degree of 5. Because it's the highest power I see. The leading term is the term with the highest degree. So again, this one here, this term's written first. This is the leading term, okay, because it has the highest power of 9. It's actually the leading term, so we should write it first. if we want to put it in standard form correctly. The leading coefficient is the coefficient of the leading term. So if we go back to this guy, radical 2 is the leading coefficient. Okay, over here, highest power is a 5, so 7 is the leading coefficient. Okay, so the standard form for this, and this is kind of a fancy way of writing it, but basically they're just saying the highest power goes first, all the way down to constants go on the end. Okay, so the highest power, and then, so if the highest power is a 5, you have x to the 5th first, well, n minus 1 is 4, so you'd put in x to the 4th terms next and count down the way. Now, classifying, and be careful on this. This is something that a lot of students look over. They don't think it's that important to know it. It's on quizzes and tests. We're going to ask you, classify this by degree and by number of terms. This first one has a degree of 0. This would be the same thing as 6x to the 0 power. Anything at 0 power is 1, so we don't write it, so just 6. So if it's to the 0 power, it's considered a constant. And this one, number of terms, it has one term, it's monomial. We're going to see different combinations. It's not that constant always goes with monomial every time. You can have a linear go with a monomial. You can have a quadratic go with a monomial. So they can go in any combination. It's not that constants are always monomials. Here, we've got an x plus 3. Okay? The first power makes it linear. The fact that there's two terms makes it a binomial. If I just had 3x, for instance, it'd be linear, but this one would have one term, so it'd be a monomial. So all kinds of different combinations. There's no correlation between degree and number of terms. They can be any combination. Okay? This one has a square that makes it quadratic, but one term makes it a monomial. This one has a cubed as its degree, that makes it cubic. There's 4 terms, that makes it a polynomial of 4 terms. We got lazy. So they do monomial for 1, binomial for 2, trinomial for 3, and then after that they just say binomial of 5 terms, binomial of 7 terms. So they got tired of naming them, I think. On down the list, so if it's a 4th power, it's called a quartic. Think about a quarter means 4, there's 4 quarters in a dollar, so that's a quartic, and then a quintic would be to the 5th power. And again, number of terms decides what this is. Okay, so on the back side, again, a lot of this is going to seem like, oh, I've done this before. Like, we've been asked these questions before in Algebra 2, and you're right, you have been. But it says simplify, then make sure you put your answer in standard form, then classify. So first, I'm going to subtract. And remember, when you're subtracting a binomial, make sure you subtract both of these. So I'm subtracting 4n squared, and I'm subtracting a negative 5, which actually means plus 5. So 2n squared minus 4n squared is negative 2n squared. And then 8 plus 5 would be 12. Okay, now this one here, it's the highest power is a 2, so that makes it a quadratic. And then there's 2 terms, which makes it a binomial. Okay, over here, we're adding, so look for like terms. Here's my squareds, 13x squared. Here's my linear terms, so that'd be a negative 3x, and then you got minus 5. Again, it has a 2, so it's a quadratic, but it has 3 terms, it's a trinomial. Okay. If you want to, try to pause. Try the next 2, maybe pause and try them out, see what you get. In fact, I might pause the video here and I'll just write the answers down and save some time. So try them out. See, quiz yourself real quick, see if you can do these and name them correctly. Okay, so this one, again, when you're subtracting, make sure you subtract all the terms. So I switched, subtract 5x cubed and so on. Got that for an answer. Highest power is 3, so it's a cubic. There's 4 terms, so it's a polynomial of 4 terms. Here I'm adding, so just add like terms. Got that for an answer. Highest power is a cubic, so it's a cubic, or it's a cube, and then it has 4 terms, so it's a polynomial of 4 terms. Now let's try multiplying, and then we're going to do the same thing. We're going to multiply them together, and then we're going to name them. Okay, so this first guy here, going to FOIL, so it'd be x cubed plus 9x squared minus 3x minus 27. Cool thing about this, no like terms add together, so we're done. Now it's a cubic, and it's a polynomial of 4 terms. If at any point you feel like you want to pause and try them out on your own, go for it. This one here would be 2x squared minus 3 times 2x squared minus 3. I'm just going to write it twice instead of saying squared, and then do your FOIL. So 4x to the fourth minus 6x squared minus 6x squared plus 9. Now don't stop here, combine like terms. So 4x to the fourth minus 12x squared plus 9. Now this one has a fourth power, so it's a quartic, and it's a trinomial. Okay, I might just do, just to save time on the video, I'll just do this first one and know that all of these are distributive property. So for this guy here, I'm going to distribute the x squared to both of those. So x cubed plus 8x squared, and then distribute the 10, so 10x squared plus 80x. Now distribute the negative 7, so minus 7x minus 56. Look for like terms. My x squareds, then my x's, and then the constant on the end. So it is a cubic because it has a third power and it is a polynomial of 4 terms. Okay? So like I said, I think we've done these before. We've done some of these. This one here, you got to distribute the x squared among all of them, then the negative 6x to all of them. And in fact, if it helps, I've seen people do it like this. So do x squared, negative 6x plus 4, and then up here, negative x squared plus 5x minus 1. Then multiply everything together, and then that'll help you fill it out quicker. So if that helps you, go for it. But that's the kind of the gist of it all, is multiply together and then classify it down here by what's written by the table.